Could a lighter, faster tank, packed with cutting-edge technology, transform the landscape of modern warfare? Over the past few decades, China has poured significant resources into modernizing its armored forces, aiming not only to bolster its defensive capabilities, but also to showcase its rising defense industry prowess. The Type 100, a futuristic tank built on China's modern technological trends, stands as a prime example of this leap forward. With a lighter design, advanced electronics, and state-of-the-art active protection systems, it reflects how China is approaching contemporary warfare, where drones, guided missiles, and data networks are reshaping tactical strategies. So can the Type 100 set a new benchmark for 21st century tanks? Discover right now. The emergence of the Type 100 tank didn't happen overnight. It's the culmination of a journey spanning over 7 decades. Back in the late 1940s, when the People's Liberation Army began acquiring hundreds of tanks from foreign sources, the foundation was laid. Most of these were American and Soviet tanks left behind after World War II and China's Civil War. This large influx of equipment not only helped form the first armored units, but also gave Chinese engineers their initial exposure to mechanized technology. A major turning point came in the mid-1950s when the Soviet Union transferred blueprints for the T-54A tank. From there, China began producing the Type 59, a domestic version of the T-54. Over the next few decades, thousands of these tanks were built, becoming the backbone of China's armored forces. This era focused on replicating existing designs while adapting them to the country's vast and varied terrain. The Type 59 saw action in numerous real-world scenarios, highlighting the critical need for an independent armored platform. By the 1970s, through reverse engineering and studying more advanced tank designs, Chinese engineers developed the Type 69. This model introduced upgrades like infrared night sights and a stabilized turret system. While it couldn't yet match the top Western tanks of its time, it marked a significant step toward innovation rather than mere replication. During this period, the need to secure China's northern and western borders drove a surge in mass production, putting immense pressure on factories. Entering the 1990s, the Type 96 and later the Type 99 emerged, bringing Chinese tank designs closer to global standards. These models featured composite armor, digitized fire control systems, and more powerful engines. The Type 99, weighing approximately 55 tons, could travel at speeds exceeding 50 miles per hour and was seen as a symbol of China's defense technology in the early 21st century. Though still influenced by Russia's T-72 design, the Type 96 and 99 showed a clear shift toward creating tanks with a distinct Chinese identity. Throughout this journey, each tank generation reflected the industrial capabilities of its era. From heavily relying on foreign aid to establishing a robust domestic production chain, China steadily expanded its scale and technical expertise. The Type 100, with its fresh design and forward-thinking approach, is the natural continuation of this path, a milestone that showcases a transition from learning and adapting to actively building technology tailored for modern warfare. The 617 factory is recognized as China's leading center for armored vehicle production, where advanced technological ideas are turned into reality. Covering an area of about 7.7 square miles, this self-contained complex gathers thousands of skilled engineers and workers, operating modern assembly lines that produce everything from steel hulls to sophisticated electronic systems. The factory includes its own dedicated testing grounds, with runways stretching for several miles to check mobility and performance, ensuring every detail meets strict standards. Its strategic location, roughly 75 miles from raw material sources, reduces transportation time and secures a steady supply of everything from high-strength steel to advanced technological components. This is envisioned as the birthplace of the Type 100, a conceptual battle tank. The 617 factory does not simply manufacture, it also integrates research and development, enabling rapid testing of new concepts. From casting turrets to integrating control software, all processes are carried out within one closed ecosystem, shortening the path from blueprints to working prototypes. This offers a major advantage in creating tanks designed to meet the demands of modern battlefields, where speed and flexibility are matters of survival. The 617 factory demonstrates China's industrial capacity, yet it also faces challenges in quality control and workforce training to sustain production at scale. Can such a facility allow China's armored industry to compete with powers like America or Russia? And in your view, what factor is most critical for a plant like the 617 to build the tank of the future? The standout feature of the Type 100 is its embrace of a medium tank philosophy, breaking away from the trend of developing heavy tanks. Weighing around 40 tons, approximately 88,000 pounds, it's notably lighter than models like the Type 99 or the M1A2 Abrams, which tip the scales at 60 to 70 tons. This reduced weight not only boosts mobility, but also simplifies transportation by rail, road, or ferries with limited weight capacities. In the context of modern warfare, rapid deployment across diverse terrains is increasingly vital, especially in regions with underdeveloped infrastructure. The Type 100's turret is designed to be unmanned, a significant leap forward in enhancing crew safety. The crew, now reduced to just 2 or 3 members instead of the traditional 4, operates from a heavily armored, isolated compartment, completely separated from the ammunition and loading systems. This setup minimizes risks in the event of a hull breach. However, fewer crew members mean a heavier workload for each, requiring robust support from automated systems and advanced combat management software. The primary weapon of the Type 100 is a smoothbore cannon, assumed to be 105 millimeters. In theory, this is smaller than the 120 millimeter standard used by NATO or the 125 millimeter guns in Russia. Yet reports from Chinese military sources suggest that new propellant and advanced armor-piercing rounds achieve a muzzle velocity of around 577 feet per second, capable of penetrating up to 25 inches of homogeneous steel at a range of 1.2 miles. If these specifications hold true, its firepower rivals larger caliber guns while maintaining a lighter overall system. Another detail showcasing its adaptation to modern combat is the redesigned side armor and side skirts, engineered to minimize damage from armor-piercing rounds and shrapnel. The hull and turret are lower, reducing the tank's detectable surface area. With a length of about 23 feet and a height under 7 feet, the Type 100 is far more compact than its peers, making it harder to spot by radar or reconnaissance drones. A key highlight is the design's flexibility. Tanks are no longer solely about thick armor, big guns, but strive for a balance of mobility, firepower, and electronic integration. By cutting weight and restructuring crew layout, the Type 100 reflects a fresh perspective on the tank's role in the 21st century. Rather than serving as a battle fortress for direct confrontations, it functions as a highly mobile platform, ready to coordinate with drones, active protection systems, and support vehicles in a multi-dimensional combat environment. Speculation suggests a striking feature of the Type 100 is its diesel-electric hybrid propulsion system, delivering approximately 1,500 horsepower, equivalent to about 1,120 kilowatts. This isn't merely a mechanical upgrade. It marks a shift from viewing tanks as basic machinery to treating them as mobile energy platforms that power complex electronic systems. In electric mode, the hybrid system enables the tank to move with significantly reduced noise, a critical advantage in scenarios requiring stealthy approaches without detection through sound, while providing instant torque for enhanced lateral and reverse mobility. The hybrid system's substantial power generation carries both tactical and technical significance. Within the same chassis, surplus energy can fuel a 360-degree scanning radar, electro-optical sensors, active protection systems APS, drone control stations, and real-time data processing computers. In essence, the tank evolves beyond a mere weapon platform into a mobile sensor hub, contributing to a digitized battlefield picture. When needed, this energy can also launch reconnaissance drones or rapidly charge electronic weapon modules on site, boosting endurance during independent operations. However, transitioning to a hybrid and electrified system introduces significant technical challenges. First is the cooling issue. High-power electrical sources, inverters, and batteries generate substantial heat, requiring sophisticated cooling systems to ensure long-term reliability. Second is maintenance and supply chain complexity. Batteries, inverters, sensors, and control software demand highly skilled technicians and specialized spare parts, increasing the need for extensive spare inventories, repair stations, and training programs. Third is cybersecurity and electromagnetic interference. Operating multiple connected electronic systems heightens the risk of hacking, signal disruption, or electromagnetic interference, necessitating robust technical solutions and strict operational protocols. Additionally, operational logistics are transformed. While diesel fuel remains essential for the engine, electric power requires a new approach, from mobile charging stations and swappable battery modules to on-site energy replenishment solutions. Standardizing electrical modules and designing for quick battery swaps could determine real-world deployment efficiency. Tactically, the hybrid system unlocks new combat approaches, faster shoot-and-scoot maneuvers, short-range silent attacks using electric mode, or extended sensor operations without relying solely on fuel resupply. Overall, the hybrid engine and electrification not only enhance individual tank capabilities, but also reshape how an armored force operates in modern combat environments, provided technical, maintenance, and security challenges are addressed cohesively. Type 100, a conceptual battle tank, is envisioned as a response to modern threats ranging from anti-tank missiles to unmanned aerial vehicles. Its active protection system works like an intelligent shield, detecting and neutralizing dangers before they strike, giving the vehicle a higher chance of survival on the battlefield. Unlike older systems that relied on explosive fragments, the Type 100 uses small interceptors capable of self-guidance to destroy incoming targets from several hundred feet away. This technology allows the tank not only to counter armor-piercing rounds, but also to deal effectively with compact reconnaissance drones that have become increasingly common in today's conflicts. Combined with 360-degree radar and electro-optical sensors, the protection system enables the Type 100 to track threats from every direction, from guided missiles to small quadcopters. The data collected is processed in real time, helping the crew make fast decisions in complex combat environments. One of the biggest advantages of this system is its ability to provide protection not only to the tank itself, but also to surrounding units, building a mobile defensive network. For example, if an unmanned aerial vehicle approaches within 1 mile, the radar can detect it and activate an interceptor to eliminate the danger before it comes close. However, this system is not without challenges. The active protection system requires a tremendous amount of energy, equivalent to several hundred kilowatts, to operate radar and launch interceptors. That demand places pressure on cooling systems that must manage the heat from electronic components. In addition, maintaining a stockpile of interceptors and servicing the complex machinery requires skilled technicians and a reliable supply chain. In real combat scenarios, such as dense urban areas or zones with heavy electronic interference, the effectiveness of the protection system can be reduced, which means advanced software must be used to distinguish real threats and avoid accidents involving allied forces. The technology behind the Type 100's protection reflects a worldwide trend. Modern tanks now need multiple layers of defense to deal with diverse dangers. The big question is whether such a system can truly reshape how tanks operate in future warfare. Which technology do you believe is the most important to counter unmanned aerial vehicles? In modern design, a tank is no longer a standalone system. It functions as a node within a larger combat network. With the Type 100, this concept is embodied through the integration of accompanying vehicles and the ability to deploy reconnaissance unmanned aerial vehicles alongside an augmented reality display for the crew. Rather than relying solely on raw firepower, the vehicle becomes a mobile sensor hub where data about targets, routes, and the battlefield condition are collected, processed, and shared in real time. A key component is the supporting unmanned vehicle, a small platform that can operate autonomously or under remote control, equipped with a light cannon or launch rails for loitering munitions. The principal roles of this companion vehicle include forward scouting, target identification, launching small unmanned aerial vehicles, and supplying an additional layer of protection against threats from above. When coordinated together, the main vehicle, the Type 100, and its support platform form a spotter-shooter chain. One element detects and tags coordinates while the other fires or directs precision weapons. Unmanned aerial vehicles occupy the central role in this model. Because they can scout well beyond direct line of sight, unmanned aerial vehicles extend the detection range by many miles and provide still imagery, video, and sensor data to the crew. Data from these unmanned aerial vehicles is integrated into a networked warfare system that can automatically classify targets, suggest priority levels, and transmit precise coordinates to weapon systems. This compresses the kill chain, the sequence from identification to neutralization, and speeds decision-making in fast-moving combat situations. On the human-machine interface side, the Type 100 is described as incorporating augmented reality goggles for the crew, combined with digital mapping and sensor feeds. Operators can see virtual information layered over the real landscape, with target markers, alerts tied to the active protection system, and action commands. This mechanism is similar to advanced displays used on combat helicopters or modern aircraft, but it is adapted for the confined space inside an armored compartment. Operational doctrine places great emphasis on connectivity. Each armored unit operates on a synchronized data channel where vehicles, support platforms, unmanned aerial vehicles, and commanders share the same unified battlefield picture. When an unmanned aerial vehicle detects movement, the information is sent to the vehicle's command center, automatically cross-checked with radar and camera data, and used to recommend an appropriate response. This approach reduces the need for voice communications, accelerates reaction times, and minimizes human error under high stress. However, this model demands high standards for communications, infrastructure reliability, cybersecurity, and signal management. In environments with heavy electronic interference or when communications are disrupted, the value of the sensor network declines. Therefore, alongside system integration, robust backup data solutions, anti-jamming protocols, and autonomy modes for each platform become essential to ensure real-world performance. Overall, the supporting ecosystem not only amplifies the capabilities of each vehicle, but also transforms operational organization, shifting from individual action to coordinated data-driven cooperation, a clear evolution in operational thinking for the digital age. Recent military developments have driven a clear series of technical lessons, prompting weapon designers to readjust their design priorities. In the modern combat environment, unmanned systems and compact guided weapons have changed the nature of threats. Continuous reconnaissance capabilities, precise long-range strikes, and flexible deployment require ground platforms to adapt toward enhanced sensors, reduced exposure areas, and improved self-protection. Reality shows, as observation reports note, that direct confrontations between two heavy tanks are now rarer. Instead, diverse coordinated threats, from small reconnaissance systems, unmanned aerial vehicles, to anti-armor missiles capable of top-down attacks, demand more comprehensive defense measures. A direct consequence is the shift in design thinking. Mobility and sensors become top priorities. The ability to move quickly, change positions, and perform shoot-and-scoot cycles helps reduce long-term detection risks. At the same time, modern radar and electro-optical sensors increase detection range, allowing threats to be identified at safe distances. Combined with that, active protection systems APS are considered an indispensable part to handle threats from above or blind angles that static armor has difficulty responding to effectively. This trend does not appear in isolation in one country. Many major forces around the world are testing or deploying lighter tank variants, active protection systems, backup power for sensors, and integrating unmanned aerial vehicles into reconnaissance cycles, from developing medium-weight vehicles to strongly integrating networking capabilities. These programs reflect a common awareness. In an environment where data almost decides, ground platforms must become sensor nodes as well as combat platforms. This leads to a series of operational consequences, requirements for secure communications, standardized data protocols, and the ability to keep networks operational under jamming conditions. From an operational perspective, the next lesson is the importance of training and new operating procedures. When a system integrates multiple sensors, making decisions based on real-time data, the human role shifts from direct operation to monitoring, analysis, and making tactical decisions based on synthesized information. Therefore, training programs must enhance data analysis skills, understanding of information security, and coordination between ground units and unmanned reconnaissance. Finally, the lesson on logistics and technological sustainability also stands out. Deploying high electronic platforms and hybrid propulsion systems requires a supply chain for spare parts, maintenance facilities, and flexible energy replenishment methods. Investing in on-site repair capabilities, modularizing components, and standardizing data exchange becomes important to ensure operational continuity. Thus, from a technical and operational perspective, the common trend is not simply increasing or decreasing size or firepower. It is the process of restructuring the role of tanks from independent firepower vehicles to a node in an integrated sensor and combat network, suitable for the rapidly changing technological context. What do you think about this topic? Please share your thoughts in the comments section below. Don't forget to hit subscribe so you don't miss the latest analyses on technology, national strategies, and inventions shaping the future. Top 10 Discoveries Official will be back with untold stories, projects challenging limits, and quiet revolutions with global impact. See you in the next video.